Excellent. Let's kick off. Welcome, everyone, to this webinar on climate change scenarios, hosted under the auspices of the Economics MIG of the IFoA. My name's Alex Waite. I'm going to be chairing today. I'm delighted to have Sandy Trust, our guest speaker today. For those of you who don't know Sandy, he's the former chair of the Sustainability Board of the IFoA. I think you were on that board, Sandy, since 2016 or something like that.
Yes,
so quite, definitely an expert in this area, and partly through that, collaborating with a number of different organisations. He has co-authored a number of authoritative reports on climate change in all its different guises, and indeed the next one is on the question of climate change scenarios and is coming out early in July. So really delighted to sort of get a preview of that coming through today. What I need to do before we kick off is a little bit of housekeeping. We are being recorded, so if you don't want to be recorded, then please turn off your video, turn off your audio. If you're happy to, it'd be really nice if a few people could keep their video on just so we can see the reactions. Do also put stuff in the chat. I will be monitoring that. So if there are any questions that come up, I can interject at the appropriate point. And also do use the reactions and all those sorts of things, because we've already tested, Sandy can see those. So do leave your video on, obviously turn your microphone to mute, and we have about an hour for this session. We're due to finish at 1 o'clock. What we've said is we will have half an hour of Sandy's presentation, broadly speaking, and then broadly half an hour of chat. I will turn the recording off for that part so that you can feel very comfortable to contribute. I think that's the housekeeping done. With that, over to you, Sandy.
Yes, good afternoon. Thank you for the invitation. A great honour to be here with the Economics MIG talking about climate scenarios. So just to get a sense of the audience, if you're familiar with tipping points, and particularly climate change tipping points, could you do the thumbs up icon reaction on Teams? So if you're familiar with tipping points, do a thumbs up or a hands up, just so I can kind of get a sense of the audience. Yeah, a couple of people doing thumbs up. So I'm getting a reasonable degree of familiarity with tipping points and that kind of stuff. This was the previous paper, which I think Alex circulated, Climate Emergency Tipping the Odds in Our Favour. A very high quality and excellent paper, if I say it myself. Everybody should read it. But more seriously, we wrote this paper. Oliver, Lucy, myself went to a tipping points conference at Exeter University last year, but I guess was it anyway, let's say a year ago. And we met David King, and we met others. We said let's do a paper on tipping points, and that was really this first paper, and a collaboration with scientists. And the paper I'm talking about today is the second paper in that series. So I think there's a real opportunity for actuaries to work with scientists to bring together the risk management mindset with the climate science and the so what for financial services. And if we talk for a second about the difference between scientists and risk managers or actuaries, I'm sure this is not new for many of you. Scientists would typically be careful about saying that there's an iceberg until they're really confident there's one present. They don't want to publish until they're really sure, all that kind of stuff. They're more concerned with making predictions than managing risks, and that tends to be what informs economists, and that tends to be what informs policy. Risk managers, of course, have a completely different mindset. There could be an iceberg, so we should steer well clear of it. Let's reduce speed, post more lookouts, etc. And we're more concerned with what's the worst that could happen. How can we keep this pension scheme or insurance company solvent? With climate change, this is no one's job. really to do the risk management. There are lots of people doing science, but it's not really anyone's job to do the risk management. So I think there's actually a real role for the profession here. Who agrees with this statement? Do you think this is alarmist? Do you think this is realistic? Do you think it's too strong? Do you think it's a bit nuts? Maybe people could just put a word into the chat. I'll try and have a look at the chat. Just to say, what's your reaction to that statement? Too much? Too little? Realistic? Alarmist?
Can I ask, how do we put things in the chat in this software? I can cope with Zoom, but I don't know how to use this.
There should be a button at the top that says chat, and you press on that, and that will give you a side panel which will enable you to put in chat. It's possible that if that's not there, then it's possible that you've gone in through the browser and you haven't got it. So if we don't,
I've gone in through the browser. I've gone in through the browser.
It's possible that you haven't got that available.
Yes,
I've got. I do have. Sorry, I've clicked on something and it's come up.
Excellent. Cheers.
Fantastic. So lots of agreement. In particular, Tim Hodgson agrees with it completely, and that's good because he wrote it. So it would be surprising if he didn't. Yeah, I think that. I think that as well. And this you'll be familiar with. Some of you will be familiar with as well. This is the mother of all tipping points. So if we manage to tip the Earth system over a kind of basically a Holocene threshold into what people refer to as the hot house Earth, where we trigger runaway warming and the ecological niche in which we've existed and which our civilization has developed ceases to exist. So that's really the name of the game, trying to avoid this.
Is there a way other than talking about GDP to get the point across, because it's going to seem less real using that wording than I would have thought other wording? Or is it a case of you want to get through to economists so they are triggered by the word GDP? Is that what it is?
That is a great question. So I think there is lots of other wording which you could use. I guess we'll get into this a bit. The specific issue we're really trying to address here is the disconnect between what the scientists are saying, extinction level event, cataclysmic, all that kind of stuff, and what some of the economic models are saying. And as the scenarios paper, I'll get into this, but as the problem we see is that economists are producing very low estimates of GDP impact. So the scientists are saying this could be really bad, everything could fall over, involuntary mass migration, deaths, sea level rise, and the economic models are saying, don't worry, it's only going to cost 2% GDP. And so that disconnect at best makes the models a complete waste of time, but at worst makes a lot of people think, well, actually, if the GDP impact isn't going to be too much, do we really need to worry about this? Is there really that sense of urgency? So that's so yeah, great point. There's lots of other language. We've kind of focused specifically on GDP because we think that's one of the big issues. Tipping points I won't go into in lots of detail, but there are a bunch of tipping points or tipping elements in the global climate system, and we all deal with tipping points all the time. I have a glass of water on my desk. If I accidentally knock it, I could catch it before it tips, or it could tip over and spill water, and I could mop it up, but it's now more difficult to put the water back in, or it could fall off the desk and smash. So it's in an entirely different state, and it's very difficult to get it back to the previous state. As with glasses of water or milk or wine, so with elements of the Earth's climate system, to pick one or two, the Greenland ice sheet loses elevation as it melts. Once it goes beneath a certain altitude, it becomes significantly warmer and goes into kind of runaway melt. The Arctic Sea ice, as it melts, you lose the albedo and you get the double whammy of the darker ocean absorbing heat. So that's going to tip to an ice-free state. And scientists would say that one probably has tipped, and there are a range of estimates as to what temperature some of these major Earth elements start to tip. Obviously, they're not independent, they cascade, they're related, and all of them act to either further accelerate global warming by releasing gases or to accelerate the impact. So really incredibly serious stuff. I've kind of talked about what a tipping point is. I won't go through that in detail, but it's going from one system into another. Think about a football in a skateboard bowl and kicking that. As long as you don't kick it too hard, it's always going to go back into the bowl, kick it out over the edge, and it goes miles. So a classic characteristic of complex dynamic systems, and extremely nonlinear, and can be practically irreversible. If you think about the weather conditions that led to the build-up of the Greenland ice sheet, we would have to go to a much colder climate for that to kind of regenerate. So again, I won't go through this in lots of detail, but this was kind of the basis for the paper I'm going to talk about today. We've underestimated climate change progressing much faster than expected. Climate tipping points. A really important point is that, which I'll dig into later, is that the Earth is a very complicated system, and Earth system modelling is very uncertain. So carbon budgets are very probabilistic, and in fact, we have a quite low probability of limiting warming to 1.5, even if we keep to the net zero carbon budgets. We will need to remove GHGs from the atmosphere. We will need to, consciously manage the atmosphere. And tipping points mean uncertainty, which uncertainty we're used to in financial services. We look at scenarios, we have margins, we introduce prudence. That's missing from climate change currently. Oh, sorry, I've clicked a link. 2 seconds. And that's still working. Still working on your screen. So again, I won't go through lots of this in detail, but what this shows, you can see the bars as you 5 kind of impacts climate change, 8E, the x-axis is time, and what those bars are showing is that the level of risk is increasing over time. The temperature on the y-axis, the temperature at which bad things happen, is consistently been estimated to happen at a much lower temperature. So sort of 15 years ago, scientists were saying bad things won't happen until we get to 7 degrees, and now they're saying bad things are going to happen at 2 degrees. Sea level tracking is, near upper limits. Arctic amplification much earlier than and permafrost much earlier than projected, and we continue to emit in line with the high emission scenario. Tipping points I've talked about. Net zero budgets are probabilistic. I think net zero budgets for 1.5 degrees are now negative, probably. And if you look at that, there's a big error range, over 100% error range on carbon budgets, and a lot of assumptions which underpin carbon budgets, which are not true. So they assume that, for example, methane isn't going to increase, but that's at an all-time high. So the assumptions that underpin these carbon budgets, which are already uncertain, do not hold. So the carbon budgets are either smaller than we think they are, or we're dealing with a lower probability. So this is our new paper, which is published on the 4th of July with University of X. It's the first paper we published with Sir David King, who's a well-regarded climate scientist. This paper we're working with Tim Lenton at Next University. Tim was the first scientist to publish on tipping points. Again, a very, very respected Earth system scientist. And I think the headline for me is the Earth's climate may be more sensitive, and in fact, much more sensitive than we thought. If I just pull out a quote from one of the supporters, this is from Nigel Topping, who some of you may know as the COP26 climate change champion. We've had some great people supporting this paper. And helpful when you're talking to the PRA to have someone saying that everyone who cares about the stability of our financial system should read this paper. And I think really when you look at current climate change scenario analysis in financial services, there's been a massive effort, a massive increase in skill, and a massive increase in the use of climate scenarios, but we're thinking quite linearly. We're not really thinking about how things happen in the real world. And for me, the scenarios are understating the risk because they're linear and they don't capture all the risks. So here are our key findings. Climate scenario models in financial services are significantly underestimating risk. I'll talk about why that is. Carbon budgets I've mentioned, I think they're smaller than anticipated, and risks are developing more quickly if the planet's warming more quickly than we anticipated. And regulatory scenarios are, hats off to the regulators. They've pushed the industry an awfully long way, but many companies, many people will say, well, we just use the regulatory scenarios because NGFS or PRA have done all the thinking. So we just use those. We don't need to think too much about the limitations and assumptions. So digging into this a bit more, why don't these results make sense? Chip in or type something if you like. I think most people seem to agree that we could see 100% GDP loss or similarly catastrophic impacts. And yet, if you look at the difference between the orderly and the hothouse, you can see that the hothouse world for institution 1 is marginally more economically positive than orderly transition. Some are the same, and a couple of institutions have a negative impact on the hothouse world. So the biggest negative impact being a 1% hit to returns per annum, which is, I think it's like a 30%, 40% asset portfolio hit, so still significant, but still not in line with what we think could happen.
Andy, let me just interrupt you if I may. A question's coming on the chat, which is to try and put some kind of time frame on this, because obviously at the heat death of the universe, then there will be no GDP. But in your mind, are we talking here 20 years, 100 years?
30 to 40, so 2050, 2060.
Correct. Thank you.
Yeah, no, absolutely. Over 20,000 years, it's going to be different. Certainly this century. So what's going on here? Why are we coming up with these benign results? Well, if you think about scenario modeling, it's clearly a very complex process, lots of assumptions, lots of things to think about, lots of complex models, the Earth climate model, picking emission scenario, etc. But really, we're concerned with each scenario we model. We're really talking about physical risk here in hothouse, although the same principles hold for transition risk modeling. What level of emissions will we see? How much is the Earth going to warm? Because that's going to drive the damages. So if we look at scenario choice and emissions, most firms are picking the 3 climate scenarios sensibly that the NGFS say. But we're not really thinking about the impacts of higher temperatures. We see these benign results, and we're also not doing what we would think of as experience analysis. Stock of greenhouse gases in the atmosphere, and it's the stock, not the flow, that drives the warming, is now double pre-industrial, so 2x. And that's in line with the high emission scenario, and we know that we continue to emit CO2 and methane. So we're not really factoring that experience analysis in my opinion, and the assumptions underpinning carbon budgets don't hold. So the carbon budgets are not realistic. So regulatory scenarios are great for consistency, but don't reflect experience, don't capture the risks, aren't realistic or likely, and really importantly are not stress or tail scenarios. These are not scenario analysis in the way that we might think about them. So we do see more mature firms starting to think about this and develop views on what's likely, their own scenarios, and also developing quite rich qualitative scenarios. How much is the Earth going to warm? The key assumption here, which some of you may have heard of, is equilibrium climate sensitivity. So this is the warming we expect if we double GHGs from pre-industrial. First calculated in 1979, has remained pretty stable. Best estimate 3 degrees. So if we were to just stop today, the stock of greenhouse gases in the atmosphere, we think would take us up to 3 degrees Celsius. But you guessed it, it's uncertain. There's a range, IPCC give a range of 2.5 to 4 degrees Celsius, but it's heavy tails. It's a 20% chance ECS is greater than 4.5. But ECS simplification excludes what are called long-term feedback, such as changes in ice sheets and vegetation. So it's again not realistic. So just for a realistic estimate, you have to look at Earth system sensitivity, what will actually happen given ice sheets are melting, vegetation is changing, etc. So I think there's consensus that ESS is greater than ECS, i.e. the sensitivity of the Earth system is greater than the sensitivity of the Earth system with some factors fixed. Some scientists think double. I'm not saying that I necessarily agree or disagree with that. I'm saying from a risk management perspective, we should consider the range of uncertainty. If it was double, that would be 6 to potentially 10 degrees of warming at today's GHG levels, if we let that continue unabated. And the current rate of warming might increase to 0.3 per decade. So that's 1.5 by 2030, 2 degrees by 2050. So pretty significant, pretty profound. What does it mean for carbon budgets? Well, we've talked about the over 100% error margin given the net zero carbon budgets. Number of underpinning assumptions do not hold. Deforestation, methane levels at record highs, tipping points, etc. Emissions at circa 40 gigatons per annum. So at current rates of emissions, we blow the best estimate budget, but it's probabilistic and the underpinning assumptions don't hold. Therefore, carbon budgets are smaller, or the probability of success is smaller. So I personally think there is a real chance the carbon budget for 1.5 is now 0 or already negative. And we're seeing the planet get to those temperatures. So let's go into the modelling and why I think it's bananas. So what we do, of course, is parameterize loss distributions and models to what has happened previously. So we look at disasters, the impact on GDP, and we plot a curve and say this is what happens. Then we extrapolate and we get some estimates. Now, there's clearly lots of ways to fit a curve. This extrapolation, the quadratic, is based on economists' estimates, and what they did was they said, well, what happens when it gets a bit hot? Oh, so people do a bit less work. So we can safely say that people do a bit less work if it gets a bit hotter. But we'll also make the assumption that anybody who works indoors won't be impacted by climate change. So we can therefore exclude 87% of the economy from our analysis because they would be impacted. And by definition, it's based on past experience. So it doesn't include tipping points, sea level rise, involuntary mass migration, and a bunch of other major climate risks. So it's a deeply flawed loss function. And that's what drives these very low estimates. 2.1 GDP loss for 3% 3-degree rise in temperature, 8% GDP loss for a 6% rise. So it's a real disconnect between the climate science, the economics, and that's driven, as I've talked about, from excluding most of the risks and excluding most of the economy, and also using general equilibrium models, which I'm not the world's expert in, which have a number of underpinning assumptions that just don't hold. So we're essentially looking out from the back of the Titanic in April 1912 and saying, well, we've not hit any icebergs yet, so we should be all right going forward. So there are lots of different ways to parameterize the damage function. NGFS uses, I'm grabbing a remember the name, it's the KW paper, so I think that's Cackle and Wentz, yes, and that looks at the impact on productivity of different GDP levels, and then there are different impacts for different geographies. So, equatorial countries are much more impacted than countries at higher latitudes. BT Burke Tanutama looks at GDP growth as well as levels, so that you get a much bigger impact up into sort of 60-70% GDP impacts, but they both exclude tipping points and forward-looking risks. So I think we still have to ask the question, is it a conservative estimate of the damage function? A small point on equilibrium versus non-equilibrium models. What you see is that you get quite different GDP patterns from the black lines, which are non-equilibrium, to the grey lines, which are equilibrium. And in particular, the energy transition is GDP positive in some of the non-equilibrium models and GDP negative in the equilibrium models. I am not going to speak more about that because I'm definitely not the expert. There's a really good actuary article that's that I linked to there, and I'm sure there are people on this call who are more expert than me. But model choice has a really big impact also on damage. I won't dwell on this, but I think it's, you know, clearly on actuaries to clearly communicate limitations and uncertainties and be comfortable that they understand the key assumptions. And I think looking at those TCFD results, I'm not sure that's the case currently. So moving forwards, make sure that people, you know, education on the assumptions, the models, limitations. Yes, it's complicated, but yes, it's important. Realistic, qualitative and quantitative scenarios and model development to capture risks and uncertainties. Education, I think, speaks for itself. This is just an example of kind of a rich narrative scenario that you could start to think about the interconnectedness of risks, how they might flow through different physical risks to different societal risks, and ultimately how that might impact asset portfolios. So a number of firms I know are working with academics to develop these rich qualitative scenarios. And the good news for all of us is that they intend to publish these, I think, next month as a kind of public good. So I think the ready availability of good thinking on rich narrative qualitative scenarios is going to improve considerably. Now, here's a different way we could do it. This is credit to Carbon Tracker and Professor Steve Keen, and also Tim Hodgson knows on the call. So could we use a kind of reverse stress testing approach where I pick a temperature 4, 5, 6 degrees where we lose, you know, most of our GDP? You could say 100, you could say 90, you could say 80. But the point is, rather than trying to predict accurately a bunch of things we have never experienced exactly when it will happen, we kind of say, well, we know it's going to get really bad at some point. Let's just work backwards from then. And I think for me, the point isn't so much at what point do we lose everything, or is it 100 or 90 or 80 or 70? Because we could spend the rest of our lives discussing that. The point is more that the damage starts to ramp up between 2 and 3. So rather than the model saying, don't worry, it's not going to hurt economically, the model starts to say, worry, things are going to start to get pretty bad as we get close to 2, and really bad as we get close to 3. So it's for me, a much stronger disincentive. And if you look at that, you can start to see, if we assume 0.3 degrees Celsius per decade warming, you start to, and if you're at 2 degrees by 2050, 3 degrees by, let's say, 2070, 2080, you can start to see, you know, 50% GDP loss depending on your assumptions between, say, 2070 and 2090. So that's a very different conversation to, oh, it's going to cost us 0.1 of a percentage return per annum. And it takes, and you know, if you take a moment to reflect on what sort of chain of events would lead to a 30, 40, 50% GDP loss, it's it for me is quite profound and really reinforces that risk management mindset. What is it that we want to avoid, and how bad could it be? And then let's make every effort to delay that, because without doubt, the very benign estates of damage have definitely caused delay. So I'm not saying this is the right answer, but we propose in the paper that perhaps a reverse stress test type approach could be used to augment and to as more of a kind of tail risk scenario. So that is, you know, a pretty quick whip through some of this stuff, and I think I've just about kept to time, Alex. I'm happy to jump into questions and discussion, and you can obviously put any of those pictures or diagrams back up as needed.
Amazing. Thank you, Sandy. Really insightful. And as you said, a whirlwind tour, but bang on time. Very impressed. Thank you very much indeed. So that people can feel more comfortable, I'm now going to stop the recording and then ask people to come forward. I think if we can start actually with questions of understanding, that would be really good. Because what I'd like to